Hello everyone, welcome to our channel Civil Construction Topics. Today we are going to discuss about the topic that is carbonation of concrete. As you see in the image, this is the carbonated effect structure and it is the ultimate killer of RCC structure. Definition of carbonation. Carbonation is a process in which the carbon dioxide present in the atmosphere react with the calcium hydroxide present in the concrete. Carbon dioxide enter into the concrete through the pores present in the concrete. This is the process how the carbonation will happen. This is the calcium hydroxide which is present in the concrete. This is the carbon dioxide present in the atmosphere enters into the concrete through the pores present in the concrete, and it creates the product that is calcium carbonate plus H2O. Carbonation of concrete is one of the main reasons for corrosion of the steel reinforcement in concrete. As you know, that is, it ultimately affects the reinforcement and makes the corrosion of concrete. In general, pH of the concrete is around 12.5 to 13.5 depending on the alkalinity of the cement. Under the pH condition, that is when the pH is in the range of 12.5 to 13.5, the reinforcement is in highly alkaline environment and the reinforcement will not get corrode under the condition of pH. When the pH is in this range, that is 12.5 to 13.5, there is no chance that the steel will get corroded, as the steel is being protected by a protective layer. After the reaction of CO2 and the formation of calcium carbonate, the pH of the concrete will reduce to around 8.5. At this stage, the protective layer around the steel reinforcement will get destroyed and the reinforcement will start corrosion. As soon as the structure will affect with carbonation, the pH of the concrete will reduce to 8.5 and the protective layer around the steel reinforcement will get destroyed and the steel will start corroding. As you know, the effect of carbonation on steel depends on the atmospheric conditions. When the CO2 concentration in the atmosphere is high, there is a higher chance for the structure will to get carbonation. Here you see concentration of CO2 in atmosphere is different in different location. Higher the concentration of CO2 in the atmosphere, faster the process of carbonation and faster the corrosion. Effect of carbonation. Steel reinforcement will get corroded, spalling of concrete finally decreases the life of RCC structure. When the steel get corroded, the volume of the steel get increases and it will create stresses in the concrete and leads to spalling of concrete and finally decreases the life of RCC structure. Precautions during construction to protect from carbonation. Maintaining required concrete cover, using good quality concrete having higher density and less permeability, use of epoxy coating on reinforcement steel or inhibitor solution, application of anti-carbonation coatings on structure. If you maintain the required cover depth, ultimately it will give better protection to the RCC structure. And one more thing, using good quality concrete having higher density and less permeability. Either water or carbon dioxide or air, anything will penetrate to the pores present in the concrete. If you use a concrete having higher density and having less porosity and less permeability, so in that case it doesn't allow carbon dioxide to enter into the concrete and will protect your structure from carbonation. Use of epoxy coating on reinforcement steel or inhibitor solution. When you apply a epoxy coating on the steel, it will also protect the reinforcement to get corroded. Application of anti-carbonation coatings on structure. Measurement of carbonation depth. Carbonation is measured by carbonation depth either in mm. In case of carbonation, if the carbonation depth exceeds the depth of concrete cover, it leads to the corrosion of steel. The depth of carbonation is measured by phenolphthalein indicator. I will show how it will measure in the image. You can see here measurement of carbonation depth. In this image you see here there are two colors. Some part of the concrete is in pink color and some part is in normal concrete color, that is gray color. To measure the depth of the carbonation, you need to cut the core from that particular structure and and should break the structure in two parts, that is in the center, and you should spray phenolphthalein indicator on the structure. Here the structure that is affected with carbonation, you didn't find any color change, and the structure that is not affected with carbonation, you can see that is color changes, which is in pink color. The process of phenolphthalein indicator, when the concrete having calcium hydroxide, it will changes into pink color. When the concrete doesn't having calcium hydroxide, which is in gray color. Initially you have in concrete you have calcium hydroxide, so it is in after the reaction of with CO2, the calcium hydroxide will convert into calcium carbonate. This is the part of the structure that is affected with carbonation. You can see here the depth of carbonation is around 15.65 mm. If the carbonation depth reaches till the cover of the concrete, the reinforcement will start corroding. I think people have understand it clearly. And the image this is one of the images showing carbonation effect on steel structure. Here you see that steel structure affected with carbonation, and the steel reinforcement got corroded and absorbed the spalling of concrete. This is also another image showing carbonation effect on structure. Anyway, thanks for watching. Please do like and subscribe.